Hear me? Thank you for joining me today in Epidemiology Everyday at 9 p.m. Australian Eastern Standard Time. It's Dr. Kazi Rahman here. Today we are going to catch up once again with the concepts around role of chance, and we'll talk about sample size calculation again. Yesterday, I spoke in detail about these two concepts. I did some drawing, and I thought that I would go back to them again, and I'll have a recapitulation of those concepts today, because I was a bit haphazard yesterday when I was doing all those drawings and everything. Hope you are doing well. So let me change the direction of the camera to my drawings from yesterday, and then let's start discussion. So yesterday we were dealing with these two things. One was the errors that can happen by chance, that can happen by randomly. And the other one was, we talked about sample size calculation. We spoke about one sample and two sample situations or scenarios. Now let's have a look at the errors first. This one. We discussed 4 different scenarios. And the first one is, suppose you are doing a study and you want to find an association between X and Y. And in your study, you find no association. And the truth is also the same, that there is no association, which means that the null hypothesis is true. And then you are actually landing on this page, on this cell, which is correct. Now, what about you find an association? That means you reject the null hypothesis, but actually there is no association. Then you are actually here, which is quite risky. It's like someone who is not guilty, or someone who hasn't done any crime, you are saying that that person is guilty, and which will result in subsequent actions, punishments, and everything. And the same applies here. You are saying that there is an association. That means then there will be further steps, further actions to be taken. So that's why this is called type 1 error or alpha, and we try to keep the level or the probability of happening of this type 1 error very low. We say that okay, up to 5% is okay, but we will not go over that. If in our study, in our hypothesis testing, we find that the probability of 5% error is more than 0.05 or 5%, the probability of committing type 1 error, then we would say that no, our study findings are not statistically significant, although that 5% is quite arbitrary. Sometimes these days we use more, about 95% confidence intervals. How about this cell? This is called type 2 error, where there is actually an association, or there is actually a difference. But our study is saying no, there is no difference, or our study fails to identify or detect that difference. That is also an error. We call it type 2 error. And both type 1 error and type 2 error, the possibility of those happening can be reduced by having a larger sample size. Now, 1 minus type 2 error or 1 minus beta is power of your study, which means the capability of your study to detect a difference or an association when there is an association, which is good. And we want our study at least to have at least 80% power, or 90% is that would be even better. Now, when we calculate a sample size comparing between two samples, for example, you're comparing, yesterday we were discussing that if we are comparing the complications happening from two different types of surgeries, one, for example, in one surgery, 5% of the patients can have a complication. In the other one, 15% are having complications. Then whether this difference, like how many individuals we need to detect this difference in a study that we are conducting. And for calculating sample size for that study, this is a two sample scenario because we are comparing between two groups of people. We're comparing between two different proportions. And for calculating a sample size for that study, we need to consider alpha. We need to assume an alpha. We need to assume a power. And also that P1 and P2, the two proportions. What about you are just measuring one proportion in one sample? Like the prevalence, yesterday we talked about what proportion of the tuberculosis patients are having delayed diagnosis as a whole. That is a one sample situation. And suppose we're expecting that it is 20%, that is P. And 1 minus P or Q is 80%. And we'll be fine if the difference, if that 20% is plus minus 5%, like if it varies from 15 to 25, that is D. And Z is like if you think that your confidence level is 95%. And actually this is the confidence level. So this is the level of significance and this is confidence level. And if you say that your confidence level is 95, then the Z statistic for that is 1.96. You can see it here. You can find that number from a table. And by doing from this, you can actually calculate sample size for a one sample situation. And yesterday we also spoke about why we need to deal with a sample, because all our questions, all our study questions are related to our target population, but that is very, very big. And then we do our study in a particular study population, which is also quite big. So we need to take a sample. And from that sample, we come up with statistics, which actually estimates this target population parameters. So this is in a nutshell what we discussed yesterday. And I thought that I would just recapitulate them today before we move forward further. So thank you again for joining this live streaming, and we'll catch up again in our next session. Bye.